Hello, Rick here on Certifiably Ingame with a video that attempts to break down just how the various types of torpedoes in Star Trek work. But beyond the basics, I quickly stumbled into a few dead ends with that because, quite simply, the technobabble is there to mask the fact that the writers often don't know. This isn't a criticism levelled at the writers, because they do often lend a certain level of believability to the universe of Star Trek by alluding to real-world theories and science. But in the case of quantum torpedoes, for example, things get a little hazier than usual. So, with that being said, I instead decided to focus on what the actual difference is between photon torpedoes and the later quantum counterpart that was introduced around 2371. First off, let's take a look at how torpedoes in Trek actually operate. There's a lot of tech that goes into each device, especially the casings for the weapons. In fact, those torpedo casings are often interchangeable with several probe models and vice versa, especially the Class 8 casing. This ties heavily into Starfleet's mantra of adaptability, and that to them even a weapon is a multifunction tool. Run out of probes? No problem, gut a Class 8 torpedo, replicate the sensor equipment and slot it in. Need to modify a photon to deliver a gravimetric charge instead? Whip out the payload and replace it. Dead crew member? Whack them inside the tube. That may have been a little callous. But today we're looking at them in their role specifically as photon torpedoes. So we see these weapons fired at both warp and sublight speeds, but the devices themselves have no warp cores, nor expansive rig for flight, so how does that work? Well, for the most part, the photon tube or torpedo launcher acts as an accelerator that provides the torpedo with its initial burst of momentum. Then, microfusion reactors inside the torpedo activate to provide further acceleration and guidance when it is in flight, leaving a plasma wake, which is presumably the visible glow. The interesting bit comes when they are fired at warp. During launch, the torpedo grabs a handoff warp bubble from the firing ship currently at warp. The torpedo tubes generate a bubble around the projectile drawn from the vessel's own warp field. So as the missile leaves the ship, it doesn't instantly begin to decelerate from warp. Remember, it's the warp bubble that removes a ship from the relativistic effects of space travel. So without a bubble, physics begins to demand to know just what the hell you're playing at and begins to drag you back down to natural speed limits. So that would suck for a torpedo launcher, because as soon as the explosive leaves the firing vessel's warp effects, it would decelerate back into the ship that fired it. A small onboard system provides enough power to maintain a warp bubble for the torpedo, but not generate one. Therefore, a torpedo fired at warp stays at warp until the power fails, but a sublight one cannot reach FTL speeds. Although I guess you could refit the torpedo to house a small warp core like a shuttle. The unit for measuring a blast from a torpedo is the made-up isoton. The reason this was created in real life was so that inconsistencies and comparisons between real-world blasts and those in Star Trek would be hard to spot, and any inconsistencies in the writing could be hand-waved away. It's for this same reason we don't get many canon maps of the Trek galaxy and a definite breakdown of warp speeds, which needs its own video. But boy are there inconsistencies. It's stated that 25 isotons is the maximum yield for a photon, whereas quantum caps out at around 50 to 60. Star Trek Voyager then launches a 200 isoton photon torpedo like it's nothing. For a comparison, 25 isotons would level a city, while 5 million would level a solar system and create a 5 light-year shockwave. Granted, I may have skipped over a fair bit in between those two values. As you'd expect, without deflector shielding, torpedoes are incredibly powerful and can rip apart a target, both photon and quantum variants. So that is what is similar. What about what is different? Photon torpedoes are an incredibly common weapons system, on par with the disruptor for its use by spacefaring species. This is evident when we look into the technology behind them, as they are simply a matter-antimatter reaction in a guided shell. Most species in Star Trek eventually harness the power produced by the annihilation of matter and antimatter and use that to create warp drives, so it's not much of a leap for someone to put that into a bomb. Interestingly, this is reflected in the technological evolution of some other species, such as the Romulans. who preferred singularity cores in many of their vessels and developed a potent plasma-based torpedo instead of photons. Although, to be fair, the Romulans do have matter-antimatter tech and photon torpedoes, they just like being poncy contrarians. Starfleet began experimenting with photon torpedoes, well, pretty much after they cracked warp drive. Like I said, it's an easy jump to make, and by 2153 they had developed photonic torpedoes, which were the precursor to the photon torpedo. The tech involved between the two may have improved over time, but not the general principle, so many suspect that the photonic warheads we see in Enterprise are simply the same as photon torpedoes from latter Trek, just with a syllable lost in the naming convention. 1.5 kilograms of deuterium and anti-deuterium are the payload for the photon torpedo. The antimatter is safely contained by photomagnetic fields until it is needed, just like the storage tanks of a starship. When the device is fired, the deuterium and its opposites are primed and then enter the intermix chamber awaiting the trigger. By default, the trigger from the torpedo is impact, but they can be remotely detonated by subspace signal or set with a timer. A leap in photon torpedo tech was attained in the mid-2270s, when the way the intermix was achieved was altered. Instead of dumping the two together, smaller magnetic pockets were created that decreased reaction time and increased the burst energy of the annihilation. When the explosion goes off, alongside concussive forces, there is a great deal of gamma radiation released, which is supposedly high Planck energy photons, hence the name of the torpedo. There are a multitude of models and yields of torpedo divided up into marks, types and classes, with varying ranges and yields. Although with such adaptability in individual torpedoes, it does make me question why there were so many. Believe it or not, we actually have several company names from Apocrypha that list official Starfleet manufacturers of these arms, such as the Baltesha Missile Systems and Morris Magtronics. So, moving on to quantum torpedoes now, and the science behind these is more intriguing in my opinion, but makes way less sense. The theories on quantum torpedoes as effective weapons has been circulating in Starfleet since 2236, but it wasn't until 2355 that they managed to create a working prototype. Even then, the complexity of the science behind them meant that it took the threat posed by the Borg to accelerate Starfleet's research in them, producing the first viable ones in 2371 as part of the USS Defiance armaments. In essence, a quantum torpedoes are the same as a photon, except when canon says that they're plasma-based, which naturally means they leave an antimatter residue. Wait, they can't be both? Or can it? Doesn't matter, because really the method of going boom is not as important as what happens after and where they get their name. In all honesty, the exact science behind quantum torpedoes is uncertain. The point is that they increase the isoton yield of antimatter reactions by utilising zero-point energy. Somehow, matter in a quantum vacuum state, which is to say with little to no energy, the literal minimum possible amount, is twisted through some form of space-time donut-shaped deformation created within the torpedo. The energy produced by this subsequent breakdown between dimensions, yes, between dimensions, takes just as much energy from the quantum vacuum state, effectively doubling the yield. I'll be honest, I paraphrased the DS9 technical manual on that and I still don't fully understand it. Nor, judging by their rarity, does the rest of the galaxy, because for the longest time, quantum torpedoes were a Federation-specific breakthrough. However, what is for sure is that they are as difficult and slow to produce as they sound. Meaning, as of 2375, they have been proliferated throughout Starfleet, but ships still carry primarily photon torpedoes for their far, far simpler creation and use. Quantum torpedoes are tantalizingly cool because they involve the realm of science that sci-fi loves to frolic in, the quantum realms and unsolved mysteries that we still grapple with. The point is that by 2371, the Federation has a much clearer understanding of the makeup of the universe than we do currently, and therefore is better at blowing it up. Both quantum and photon torpedoes contain lots of antimatter and or plasma. which does mean that they need magnetic containment on at all times to prevent the anti-deuterium from touching anything. This means that technically the torpedoes are always on, just in a very low power safe mode when they are fueled up. More can be manufactured, and in the case of Photon Torpedoes, the ship's own reserves of deuterium and antimatter can be used to supplement the armoury, but quantum torpedoes are just too complex to be rigged up on the fly. At least until the far future of Trek, where it seems quantums have become the standard loadout. I could not provide a satisfying answer as to how quantum torpedoes worked, and if I could, I'd phone CERN, or maybe someone from CERN could phone me and let me know. Yeah, well, thanks for watching this video on the difference between photons and quantum torpedoes, and the convoluted science that went into deriving their names. Surely it's not simply because they sounded cool, right? I haven't wasted my time here, have I? No, of course not. Thanks again for watching. I've been Rick, and I'll see you next time for another video. Goodbye.